Okay, the last section of this topic is about photochemical reactions. So, we mentioned at the beginning that light can affect chemical reactions. And essentially, what the light does is it starts breaking bonds. It provides the energy to initiate the reaction. The three you need to know about are photosynthesis, which you will have come across before, photography, which is photoreduction, which is a little bit a thing of the past now, but just for historic reasons, I guess it's still in the syllabus, and the chlorination of methane. These are the three reactions. And photosynthesis is going to be the most familiar of the three. And that equation, you have to learn it. You have to learn that carbon dioxide and water, in the presence of chlorophyll in plants and energy from the sun, causes photosynthesis to happen. And it does two things: it produces glucose, which is food, obviously, and oxygen. So essentially, the life on Earth, the food on Earth, everything can be traced back to the sun. Okay. If you had to guess, would you guess that that reaction was exothermic or endothermic? Yes, it's endothermic. It's taken in energy, isn't it, to take place? So, carbon dioxide and water make glucose and oxygen. Energy from the sun drives the reaction, and chlorophylls, the green pigments in plants, acts as, in chemistry we call them a catalyst for the reaction. I know the process is quite complicated, and you'll do that in biology in more detail, but we call them, the chlorophylls, the catalysts for the reaction. Photography, which is photoreduction. Now remember, reduction is a gain of electrons, so something's gaining electrons here. You have a special film, which is why it's called film, of silver bromide gel on top of special paper. And you have millions and millions of molecules of silver bromide, or particles of silver bromide, but they're actually ions, aren't they? They're Ag plus ions and Br minus ions. And you have them all over the surface of the paper in this gel. And then the sunlight, any kind of visible light, it causes the silver ions to become silver atoms. And that's why they become black. The more light you get on a particular point of this film, the more silver is produced, so the darker it becomes, and you produce something called a negative. Now, the chemistry. The full equation is silver bromide, AgBr, because it's silver plus and Br minus, becoming silver and bromine. I'll let you write that. The reduction, well, reduction is a gain of electrons. So what is gaining electrons? You've got a choice of the Ag plus or the Br minus. Which of the two will gain electrons? Yes, you guessed it. It's the Ag plus. Ag plus E minus goes to Ag solid, which is a black deposit, a black precipitate. And then you're only left with the bromide ions. You know what happens when bromide ions are oxidized. 2 Br minus become Br2 plus 2E minus. The last reaction of these photochemical reactions is the chlorination of methane. We do this in more detail next year. Basically, the sun, the UV light, breaks the carbon-chlorine bond and the chlorine-chlorine bond and causes new products to be made. This is something that was a big worry a few years ago. It's not mentioned as much now, but the chlorine in these molecules can cause the depletion of the ozone layer. CFCs are chlorofluorocarbons, and the fact that light can break the CCl bond means that these chlorines would get in the upper atmosphere and they would destroy the ozone, the O3. So essentially in this reaction we start with methane, that's methane. The chlorine-chlorine bond is broken, the chlorine attaches to the carbon, and the hydrogen that comes off attaches to the other chlorine. Then the same thing happens again with this molecule. This molecule again reacts with chlorine, and another one of the hydrogens is replaced. This molecule again reacts, and another one of the hydrogens is replaced, and so on until you get this molecule, which is called tetrachloromethane. This is a summary of the reaction we've just talked about. So you go from methane, one chlorine is chloromethane, two chlorines is dichloromethane, trichloromethane, tetrachloromethane. Don't worry too much about this. It's important you've seen the reactions, but we discuss it in organic chemistry next year. Right, what's left is the textbook questions on the pages indicated, and end of chapter questions we'll start doing next class.